Good morning, students. Myself is Srinivas, Assistant Professor, Department of ECE, Kakatiya Institute of Technology and Science, Warangal. Welcome to video lecture on Microwave and Optical Fiber Communications. Subject code U18EC702C. Topic: Reflex Klystron Oscillator. Reflex Klystron is an oscillator. It is a single cavity, variable frequency microwave generator. It is of low power and low efficiency. Principle of operation: reflex klystron oscillator works on the principle of velocity modulation. Velocity modulation means the electron beam varies in accordance with RF noisy voltage present in the cavity of reflex klystron oscillator. The velocity modulated electrons form bunching by losing energy. The amount of energy lost in formation of bunching transfer to the noisy RF field which is present in the cavity gap of reflex klystron oscillator. Construction of reflex klystron oscillator. This is the constructional diagram of reflex klystron oscillator. It consists of electron gun, repeller, cavity, and it is the repeller space, the space between the cavity and repeller. The electron gun is at negative potential with respect to anode, and the repeller is at negative potential with respect to anode. The electrons are generated by electron gun moving towards the cavity as the cavity is at positive potential. After passing the cavity, the electrons are repelled by the repeller and once again comes back towards the cavity for the second time. And that is the reason why it is called a repeller. The output is collected across the coaxial loop. Regarding construction, it consists of an electron gun, a filament surrounded by a cathode, and a magnetic focusing field is provided to focus the electron beam. Here it is the magnetic focusing field which is used to guide the electron beam throughout the tube. The electron beam is accelerated towards the cavity. After passing the gap in the cavity, the electrons moves towards the repeller which is at high negative potential. That is, the electrons are generated by electron gun moving towards the cavity, repelled by the repeller, and once again comes back towards the cavity for the second time. Under suitable conditions, the electrons give more energy to the gap than they took from the gap on their forward journey. Reflex klystron 2K25. Regarding operation, the operation of reflex klystron can be better explained with the help of apple gate diagram. Now here, basically it is oscillator. So initially we assume that some noisy voltage present in this particular cavity. If it is amplifier, in case of two cavity klystron amplifier, we have to apply the input signal. But in case of oscillator here, we don't apply any AC input, and we assume that some oscillations are present in the tube due to noise. Let us say some noise is present in the tube, and these oscillations are sustained by device operation. Now here some noise is present in the cavity, and this particular noisy voltage excites oscillations in the puncture cavity and develops the same voltage. And here the electrons which are generated by the electron gun are affected by this particular RF noisy voltage. Now here from this diagram you can observe, just assume this is the position of electron gun, and this is the position of repeller. repeller, electron gun, repeller, and this is the position of gap. That is, this is the position of electron gun, this is the position of gap voltage, and this is the position of repeller. Now here some noisy voltage, this particular noisy voltage is present in the cavity initially, and this particular noisy voltage is sustained by device operation later. And here the noisy voltage which is present in the cavity excite oscillations in the cavity, develops the same voltage. And here, due to electron gun, the electrons are generated. These for example, at this particular at this particular instant, the electron which leaves cavity gap at this particular instant is unaffected by the gap voltage and moves with the velocity v equal to v naught. V equal to v naught. The reason is, at this particular instant the RF is 0. At this particular instant the RF is 0. And the electron which leaves cavity gap at this particular instant uh, subjected to positive maximum of RF cycle, it penetrates deep into the repeller space and comes back towards the cavity for the second time. That is, which is subjected to positive maximum of RF cycle, penetrates deep into the repeller space, comes back towards the cavity for the second time. And this particular electron is called early electron, which moves cavity gap slightly before the early electron. The electron which leaves cavity gap later than the reference electron is called late electron, subjected to negative maximum or RF cycle, comes back immediately towards the cavity gap and catches up with the early electron and uh, reference electron. Here, uh, the early electron moves with the velocity v less than v naught, and the late electron moves with the velocity v greater than v naught. Here, these three electrons form bunching by losing energy. Here, our assumption is some noisy voltage present in the RF field, and after forming bunching, here the bunching is formed by losing energy. According to the conservation of energy, energy cannot be destroyed, converted from one form to another form. The amount of energy lost in formation of bunching is transferred to the RF field till the oscillations are sustained in the tube. This is the process of sustained oscillations in reflex Klystron oscillator. That is the operation of reflex Klystron oscillator with the help of Applegate diagram. You just go through the points just now we discussed. The velocity modulated electrons form bunching by losing energy. These bunches transfer energy to the RF field in the gap until the oscillations are sustained in the cavity of reflex Klystron oscillator. For maximum energy transfer, the round trip DC transit angle referring to the center of the bunch must be equal to theta naught dash is equal to omega t naught dash is equal to 2 pi n. It is equal to 2 pi n minus 1 by 4 to n pi minus 5 by 2. That is, for n is equal, small n is equal to capital N is equal to 1 3 by 4. The best time for electron to return to the cavity is 90 degrees position. Here 90 degrees position of sine wave. The bunching is formed at the position of 90 degrees of the sine wave. That is around for the first mode, the bunching is formed at 1 3 by 4 cycle from the reference electron. And for the second mode, the bunching will be formed at 2 3 by 4 cycles from the center of reference electron, and the same thing for the third mode. Practically, the reflex Klystron oscillations are possible up to n equal to 7. Now here the round trip transit time. round trip transit time means T naught is the time for the electron to enter the cavity. T1 is the time for the electron to leave the cavity for the first time, and after passing the gap in the cavity, the electrons repelled by the repeller comes back towards the cavity for the second time. That is, once again forms bunching in the cavity gap. They comes they return to the cavity at time T2. Now here the transit time is T2 minus T1. The round trip transit time is T2 minus T1, that is T dash equal to T2 minus T1, and T naught dash is the round trip DC transit time. And here V2 is the voltage at time T2, V1 is the voltage at time T1. The relation between V1 and V2 is equal to V1 e power minus j pi by 2. T naught is the time for the electron to enter the cavity, T1 time for the electron to leave the cavity for the first time, and T2 time for the electron to enter the cavity, repelled by the repeller, comes back towards the cavity for the second time. Performance characteristics: frequency, power, theoretical efficiency, practical efficiency. The theoretical efficiency of reflex Klystron, theoretical maximum efficiency is 22.7, and the practical efficiency is around 10 to 20%. Applications of reflex Klystron oscillator used in radio receivers, portable microwave links, parametric amplifier, local oscillators of microwave receivers as a signal source where a variable frequency is desirable in microwave generators. Uh, it is the power output and frequency characteristics of a reflex Klystron oscillator. It is drawn between the repeller voltage and power output. And here, this is the first mode. By varying the repeller voltage, the power output which is detected at the detector mount, which is connected at the output of the catcher cavity, uh, and this particular mode is called dominant mode, which is having more signal strength. And the next is by after reaching some minimum point, once again the signal strength starts growing, and this is called second mode, this is called third, fourth, like that. The practically the reflex Klystron oscillation modes are possible up to small n is equal to 7. And here this particular above graph is plotted between, once again, repeller voltage and frequency in gigahertz. If you observe, uh, uh, at maximum signal strength, uh, the frequency is almost same. At maximum signal strength, the frequency is almost same, and this particular frequency is called center frequency. This particular center frequency is same for all the modes in a particular reflex Klystron oscillator. Thank you. We will meet with the next lecture.